Hello, welcome to my talk. We're going to be BOF, that's correct. Welcome to my BOF, where we'll be reviewing what refactoring goals and what abstractions we deem acceptable for our project. So I'll just start out with some philosophies that I have, and please do interrupt. I mean, obviously it's a BOF, so do interrupt, but these are what I believe are some good goals, some philosophies to go by. I hope there's at least some degree of consensus, but if there's not, of course, we can solve that. Deduplication reduces cognitive burden. So when you have two things that are slightly different, two functions especially, and you see this in the tree check failed functions, where there's two or three copies that are almost identical and are subtly different in small ways, and it turns out that one of them does have extra functionality that the other two don't have, but it's not clear without looking at it really closely. So if they're slightly different, it should be clear, but we have a lot of duplication all over the place, so it's not easy at a glance. If they're the same, they should be the same. In the same vein, things that do the same thing should have the same name. The loc functions could be converted to overloads. That was, I believe, Andrew Pinsky did ask me to look at that. It might have been Patrick too as well. It was a while ago. Less code is often better, but it's not always better. It definitely isn't good to have excessive polymorphism when you have these functions that you think, oh, well, they're almost the same. You add one thing with a little flag, and then you add another flag to change its behavior. It becomes very hard to read. It becomes very, it's very hard to reason about. That's bad. But deduplication, again, as with the first point, and removal of dead routines, that's good. Less code is good, but not always better. And expressiveness matters, in my opinion. You don't want to combine two lines into one line if it makes it significantly harder to read. Obviously, these all should be fairly no-brainers. What I think is going to be more controversial is uses of modern C++, like lambdas. I love lambdas. Lambdas are great. Yes?
What does modern mean in this context? No.
The question was, what is modern in this context? And I guess templates in general would be modern. As opposed to, well, in general, right?
Yeah. I mean, for GCC, we, in terms of what we support the latest, greatest versions of C++ and all the newest stuff. In terms of the implementation language, we use the somewhat conservative subset of C++ 14 that is supported by whatever the. Jason may be able to help, whichever version of GCC we have as our minimum build requirement, and that is also parsable by Gen-G type, and is also parsable by getText.
Absolutely.
And hopefully doesn't have too many lingering bugs in the old builds of GCC that we're using to bootstrap the thing.
I suppose that's true. I did forget to consider bugs for the older ones, so that might be something that we have to figure out how to test for. But I would say variadic templates then is modern because C++ 11 supports variadic templates. And I know that, like I said, not everyone is familiar with TMP, so it's a little hard to gauge where that line should be.
Template meta programming?
Yes. Like I was able to generalize the tree check functions to a single variadic function very easily. But maybe that code's not clear to the average programmer because I'm very experienced with TMP. It also might have regressions, but that was covered before.
But when you, for example, say these tree check functions, that's not something anyone changes every other day. So if we have that in some such format that is compact and you can, by reading it reasonably, understand, I personally would take this as a learning exercise then if I see such code in GCC.
I actually fully agree, but I don't think it's a perspective that's shared by everyone.
Well,
but I do agree fully. It's like you don't have to read the utility and understand it fully to be able to use it, as long as it's a clear, as long as the API is clear. And if it's a simple use, it's not going to break either. And it comes back to reducing the amount of code. And we have a lot of code. I don't have to tell anyone that. There's a lot of code in GCC.
I mean, if I can make the distinction, it's also good to try not to be too clever.
Yes.
Maybe you cover that. The risk of, I don't, maybe it's unfair to say, or maybe this is a reflection on me. I can't figure out the wide int code that is in GCC. It's this whole set of templates involving fixed width. I can't remember them all, and it always slightly scares me when I go anywhere near that code. And maybe someone can explain it to me, and maybe it's me being a thickie. But it feels very clever, and that might be a subtly pejorative. Although maybe,
no, I agree.
I believe it had a lot of difficult constraints to achieve, and it succeeded. But yeah, and I apologize. Sorry, whoever worked on that for many months, and it may well be here. I don't mean to disparage your work, and yeah, it's performance versus compatibility versus keep moving the thing, and yeah. Sorry.
Yeah, I feel like I kind of covered that under excessive polymorphism, but I should have also, yeah, that's what the intent was there. But you're right, being excessively clever is also bad. Being clever to reduce code, that's not always a good thing. It makes it harder to read, harder to reason about. I don't think we want that. Even if I can understand it, doesn't mean that someone else is going to understand it. Usually I write in such a way that I will still understand it 1 year after. I do my best to do that. That's why I think expressiveness matters. But that doesn't mean that everyone else will, especially if it's some fancy use of the features. And just to clarify, lambdas are already allowed. That wouldn't be a change. But I'm kind of encouraging people to maybe explore lambdas, maybe.
So last week I was working on something and I thought, I'll use a lambda here. And after 10 or 15 minutes of realizing I don't understand lambdas well enough, I just went and wrote a callback instead because I wanted to get on with my day.
Yes.
But I think the case of that is ignorance on my part of
Perhaps.
There's probably a way of writing this that I don't know the precise combination of symbols to type. Yeah.
Did you perhaps try to convert it to a pointer when you were capturing something? Because that's not allowed.
I don't remember. That might well have been the
Yeah.
I started looking at std function and thought, I need to get on with this. I need to just move on and do something.
Yes. You're raising an idea to me. Maybe we need to have more guidelines around that templates kind of solve that, because now if you are, instead of passing to a callback that is a function signature, and instead take a template. Now granted, this is the performance problem, like that might actually have performance regressions if we start doing that on compile time. But that's why we have the benchmark tool in theory. So we'll just go straight to proxy objects. This is the big headliner for me. This is what I want to do. This is what I want. The names we can bike shed in all we want. Those are not final, but this is the intended API change. And the plan at the moment would be for the old way to still work, it would just be implemented in terms of the new proxy objects. And that would have some performance benefits in debug builds. Or rather, using them in the new way would have performance benefits in the debug builds, because you wouldn't. Right now, the way the accessor macros work is it checks the tree code on each access. With the proxy types, it will check it on construction of the proxy type. Now, these would be completely trivial and non-owning, so the GC doesn't need to see them, so it doesn't have to interact with Gen G type. I'm pretty sure anyway. Maybe there's some caveats. So more or less, what's important is, how do we feel about this? Do we like this? Do we like the idea of using member functions? Because I'd say, if I had to estimate, it's about 80-20. 80% of people love this and want this, and then 20% are like, I like the macros. What does this add? I'm comfortable with the macros. But
this seems like something that can try in places. It doesn't require
Yes.
a wholesale rewriting of everything,
Correct.
like some other ideas
Absolutely.
have suggested. So, I mean, I feel like, sure, give it a try. See how it works. I'm curious why you don't have a proxy for the type in.
To be honest, I came up with the example about 15 minutes ago. They're in my head, and this is actually a real problem with the that I've ran into while designing it. Is I don't know what to return from the member functions. Should we return another proxy? But then which one do we pick? Do we pick the highest level one that's possible? Or is it maybe there's a lower one? Because it could just return tree type common from dot type. I'm not sure yet. I kind of would prefer to do it that way, I think. Keep the type safety by default to make it easier. But not sure yet.
Mm-hmm.
That's the idea though. So
We might. So I did wonder about that specific thing a number of years ago already. Why the types are trees. Maybe there is a reason it came that way, but aren't they totally orthogonal to everything else that trees are?
I did get to discuss that with why am I blanking on names? David, Jason. Sorry. I did discuss that with Jason last night, and I'm currently of the opinion that we shouldn't do that. We should just leave them as trees. It's unclear of what the benefits will be, and it would be a lot of work to rewrite, but maybe in the future.
Yeah, these feel like orthogonal. It's changes you could do independently. Yes.
Mm-hmm. Absolutely, that's another point. Yes.
Right.
Things is one idea.
Yeah.
Porting trees is another.
Yeah.
Keep them separate. I don't make one.
Right. I'm just bringing this up because we have it on the screen here. But that's actually one thing I would have done first, to turn all the tree type usages into a separate tree. Call,
I think
maybe.
that this might help expose whether that's feasible or helpful as well, because we'll suddenly we'll be able to look at it and think more like, hey, every time we use type, it's always this. It's this low in the hierarchy, not this low, or maybe it's this high in the hierarchy. So if it's like not as general as we thought, then maybe we need to switch it.
Maybe I should just try that in some file and see
Yeah.
where it breaks.
I think so.
I was going to say, as far as the separation, introducing a type for types, as it were, Andrew McLeod was threatening to do that a few years ago,
Yes.
but I think he's been distracted by Ranger for the last few years. But maybe I don't know, he's not here at this conference, unfortunately. Yeah. Oh, right, yeah.
But he had some work in progress for him.
Oh, wonderful, wonderful. Yeah. Who knows? Yeah. Well, I mean, Thomas, please go ahead and do it yourself. kind of thing.
The comment was that that Andrew might be coming back to do it soon. I'm just repeating it so it's in the recording.
Just one
Hold on.
I guess minor but still indicative data point. I was at the first New Tools Call run in 2013, and there Andrew McLeod had this session about re-architecting GCC.
Yes.
Well, and here we are 12 years later.
Yes. That's kind of where I came from with this. As I started researching, I find the page for 2014,
Yes.
and I look, and I'm like,
Or 14. Yeah.
Well, then,
Where to go?
Two successive years without planning it. He did. My recollection is he did a cleanup of the structure of the header files, and
that's not complete yet.
yeah, and I have a rant about that, which I'll spare you.
No, please, because
No.
okay.
This is this is looking for solutions rather than complaining about. I don't know. Where was I going with this? So some of that went in, but yeah, don't wait on someone else if you've got an idea and you want to carry it forward.
Yes, I'm definitely of that opinion as well.
While I have the microphone, the one thing is probably worth a thing worth stating out loud is that I think everyone in the project, everyone in the community, has different comfort levels with C++.
Yes.
So, for example, and I don't want to pick on. Well, the Fortran front end. For example, I know the Fortran front-end maintainers aren't particularly keen on C++, but are kind of begrudge. What's that?
Or at least some.
Some
I think
of them,
Tobias is much more comfortable.
There's a huge number of them, and some are
Some, okay,
okay.
I have the possibly mistaken belief that, and therefore, in terms of how I've been the diagnostic subsystem, I've been keeping it the interface C-like for C. I mean, it's obviously in C++, but C-ish, and not having too many flights of C++ fancy in the interface that they have to use, if you see what I mean. And it's slightly, gradually over the years, a little bit more C++ is creeping in, but maybe that's a sort of acclimatization thing, or some would say that's the whole what's the rant about C++ and how it takes over your project. But yeah, but I mean I know I like the language. At least
I will comment that maybe leaving interfaces as C is a good idea. Lots of projects do this for many reasons. Like for example, Vulkan has a C-style API, so it has compatibility across languages. We don't have to worry about that as much, but it's a lot easier than trying to go across, maybe not ABI boundaries in our case, but boundaries between things, and trying to cross those with C++ does get difficult sometimes. In my opinion, it's kind of a weakness of the language, or maybe I'm just not experienced enough with it. But I can see the value in that. It's just use C++ locally doesn't really have much detriment, so like you're doing in the diagnostic subsystem. All right. So
there are not boundaries within GCC
Yes.
are very porous and
Yes.
poked full of holes.
yes,
So
they are. Although I do want to change that a little bit. I think I did put it in the next slide. I guess we can move on from this for now, and we can come back to it if anyone has any ideas or if anyone new drops by. This is what we don't want. That is the Clang, a portion of the hierarchy that Clang uses. It is the reason why I work on GCC and not on Clang. I don't like this. It was.
What do you like about it specifically?
It's a nightmare to go through and figure out where you want to go. I forgot to put the GCC, the partial tree node hierarchy that we have. I found it on the wiki at some point in the past, and that was very helpful for me. I look at that, it's small, it fits on one screen. This doesn't fit on one screen. It goes for pages. I can't comprehend it. It's a huge barrier of entry in my experience. I like what we're doing in GCC much better.
I mean, I think two things. Firstly, I think the one issue here is that looks like a really deeply nested inheritance hierarchy.
Yes.
And I've learned that that's usually a hard way. That's usually a bad idea. The other, and this is something of a tangent, Doxygen,
Yes.
which feels like a wait for me. It feels the fact that we don't have an official Doxygen thing feels like to me like a wasted opportunity.
Really?
The OpenSUSE have a website where I think every weekend it regenerates a Doxygen.
I think that got disabled recently.
It-
No? Okay. I recall something on IRC, someone commenting that it was not being maintained. Maybe that's been fixed since then. And we stopped linking to it because of that.
Maybe depends on what you mean by maintained.
It just broke at some point. I don't know specifically, as was a while ago, but yeah, I'm not sure.
Okay.
I've been making changes to diagnostics and I see them.
Okay. So
I mean, some of my recent diagnostics refactoring work, I should probably confess at this point, has been to make the Doxygen output look prettier, which, in fact, to some extent, it's like when you look at your code in Doxygen, it's kind of, oh, that's badly structured. I should do it this way instead, which is kind of a nice, like, getting a different viewpoint of the code.
Personally, I think that the problem with Doxygen is that a lot of the information you get from it, you can just get by reading the header. And it just feels like I'm tabbing between Doxygen and the header. It could just be unified. And that's something I actually prefer in GCC, that we don't rely on it heavily. That's just my opinion, though. Yes, no problem. It's definitely valuable because, again, it's what we don't want, or what we do want, maybe. As you observe, this is a very, it's actually not too deep because the majority are either 1 or 2 removed from the decal base class. But my big problem with it is that each separate, I guess, each small variation on construct is represented by a different class.
I was going to say, is that an inheritance hierarchy?
Yes, it is. I know it's hard to tell.
I'm kind of guessing from the I will say is actually of the GCC Doxygen, if you run it on GCC, or the SUSE Doxygen site, has, it generates these ludicrously complicated interaction diagrams at the top of each page that I always have to just scroll by because it's useless. And it's very, very complicated interactions between all these things, and I move on to like the stuff I can make sense of. So yeah, anyway,
Exactly.
Sorry.
Yeah, so I'll just really quick now because it is on the next slide, but what I personally really don't like about it is that each, oh yeah, I already said this, but I'll repeat myself anyway. Each individual construct is its own class that inherits. This becomes kind of confusing, especially when they have subtle differences again, or worse, when they are completely the same. I actually really like how we do tree codes where we have a tree code, we can have 2 tree codes that are backed by the same tree struct, and we're just using them slightly differently, or in the case of like expressions, we have the single expression one, and then a trailing array of a certain amount of operands. I actually really like that. I think it works really well. We don't need a whole new struct to represent every single construct. However, I do think that we're too afraid to add new tree codes to represent constructs. They don't have to be tree structs, although maybe sometime there's a couple I want. But if we, instead of using old tree codes such as tree list, we could add new ones that better represent the construct that we're trying to express. Something that I've kind of observed is that there is a perception that it is hard to get patches in that add new tree codes. And I don't know if it's true or not at this point, but that's the perception. And we start making patches that reuse old tree codes because of that. I know.
Pass a list or header or a tuple.
Exactly.
Which you would rather, it's like, well, I can't add a new tree code, so I'll just pass a chain of those where the first one has some meaning, the second one has another meaning.
I've done that.
Yeah.
And that patch is still sitting in limbo though, so I'm sure I can redo it and get Jacob to look at it.
Well, one reason to be conservative about adding tree codes is space.
Yes.
That I don't remember how many bits we allocate to the code at the moment.
It's 16, so I think we have a good how many is that? I can never remember. Powers of 2 somehow. 16,000?
64K.
64?
Yep.
Okay, 64,000. There we go.
I don't think we have that many tree codes, do we?
No.
No. I hadn't noticed that we had bumped it to 16. That should leave plenty of headroom.
Yes.
In that case.
Oh, we're well over 255.
Okay.
Especially when you include all the front ends. And for whatever reason, they are all used regardless of what front end you use. And it's not entirely clear why. That's something that has to be investigated, but it's not a priority for me yet. But that's my second bullet here, would be making front ends more modular, and that's something that would have to happen. One of the ideas I have is maybe we can reserve the last 32,000, I guess, for dynamic tree codes that front ends can add. And then the first ones would be the base tree codes that, yes, you can flip between them really easily for the, what's the word? In some of the functions that go through tree hooks, they just check the bit set, jump down to the tree hook immediately because it's a dynamic tree code. We have to go to the tree hooks, to the lang hooks. Haven't investigated that yet, but that's probably the one I want to look at after the proxy object. So again, we don't want to be as granular as Clang because it's a nightmare, but we can sidestep it quite a bit when we are having multiple tree codes that correspond to a single struct. As long as we're not misusing those structs too much, I think that's a good thing. One of the ones that I want to add is a kind of a tree like expression, like tree expr, where it has a trailing array of trees dependent on its tree code, but not for an expr, but for a non-expr of that. Because I've had situations where, while doing OpenMP, for things that aren't an OMP clause, or not quite an OMP clause, but I still look at it and I go, okay, well, I just need like 3 trees. That's all I need. So it's effectively a tree array, basically. For a lot of these cases, I do want a location because it's often for parsing lists of parameters. So you want a location for the open bracket and one for the closed bracket. That'd be really useful. From what I've heard, it's had pushback from maintainers in the past to add location to these trees. I don't know what the current perspective is, though. Would you be able to answer that, Jason?
I was distracted.
No problem. I'll repeat it really quick. It's adding location to tree structs for, in this case, it's to track the open bracket and closed bracket of like a parameter list. From what I understand, there was pushback from maintainers in the past due to size concerns.
I generally think it makes sense to record more locations.
Okay. So maybe that's something we can explore then. All right. Can you pass that to?
Oh, gotcha. Just a moment. I was looking up the tree def
Gotcha.
history. Yeah, as I was saying last night, it used to be that we only had the tree codes for the current front end, but that was changed in 2008. After we went to 16 bits, at which point we said, oh, might as well just have all of them, and it simplifies some code.
Did that add any extra utility, or was it just because of what we have the space now? And so we don't have to compile tree.cc more than once now. Something like that, probably.
Ian's rationale was this simplifies making GCC compilable by a C++ compiler without lots of extra casting. It also simplifies the code and the front-end interface.
A very detailed commit message, I see.
Yeah, I mean, I could say when we were talking about this the other night, like a cauldron, it was one of the cauldrons in Prague where the whole, I wanted to add all kinds of location tracking information, and I had my whole on the side thing, and there were various approaches where do we have introduce new types that have both a tree and a location T, and various variations on that. And the compromise that, well, first of all, Jason kindly pointed out that I completely missed some stuff where the locations were already being tracked, and that was a nice easy fix. Thank you. And also the compromise, which is to add just wrapper nodes that add a location around a and here's the rest of the tree
Yep.
kind of thing, which is obviously I think the concern is that every time we make a tree struct bigger, it's well, what about okay, you're compiling something huge, what does this do to the memory consumption and also, I suppose, the caching implications in terms of speed of that. And that feels like a Jakob and Richie question.
Who didn't show
okay.
up, unfortunately.
No.
Maybe they'll come in on the halfway, which...
Oh, yeah, sorry, yeah. And the advantage of the location wrap approach is that we can kind of keep the location or information around as we want it in a kind of more dynamic style, and then discard it during the optimizer.
Yeah.
And when we,
Well, I would argue that ideally the optimizer doesn't have front-end trees anymore, right?
I would love to have references back to stuff, and there's a whole, anyway.
I still think that your other project makes sense because we do, for some cases, especially James Loden's idea, where it should be, where we will need location information even into gimplification. So I would imagine that that's the solution we should go for. I imagine that's the solution we should use for that sort of case. Because we do still want location information, but they're more niche cases, I reckon.
Gimple expressions do have location information.
Alrighty. Maybe we don't need them if we do these other things. Maybe.
But they don't have operand locations, I believe. So if a Gimple binary operator I'm sorry, yeah. If, for example, you have a Gimple binary operator plus, that is, so you're doing a sign, a plus of two operands, and one of them is a global, you're reading from a global variable, and the other operand is, say, 1. That global variable is a var-decal, I believe, and the only location you have is, well, where was that declared, as opposed to the location of the name of the variable at that expression where you're adding adding it 1 to it, kind of thing, I believe.
I don't spend a lot of time on this, but I thought that there would be a separate Gimple that's loading from the variable, SSA.
I
and
imagine
that
as
would
it
have
gets optimized out, it would be just a full location, or for the full expression as a location. That's how I imagine, but I haven't looked closely either.
I guess I need to look at this, and it may be simply that the Gimplifier is throwing away the information, and we're already paying the storage cost, but not populating it, which would be very interesting if that were the case. So that's something I will add to my to-do list.
Oof. That would be very miserable.
No, it would be wonderful. It would be
Oh no, it would be wonderful if we could fix it. That's true.
We could do a small patch to get all those location information, and
That's true. When you look at it that way, it's true for sure.
the Jakob and Richie can't complete my right now. Sorry.
All right, so we'll move on to the initializer list for now. We can always come back to all the other ones if anyone comes up with anything. But this one's really easy. What do we think of std initializer list to replace var args? I hate std initializer list, quite frankly. But I've looked at situations recently. I've noticed that could make things better. It is better than var args when you don't need different types. So, I don't know. What do we think? Any strong opinions against?
There's some tension between that and the proxy type things. It's
Yes,
easy
that's
to have
true.
an initializer list of lots of trees if everything is a tree. It'd be more complicated if you're trying to give things different types.
Yeah. If the cases I'm thinking of take a tree code explicitly, so you have to, the uses of that already do the tree code macro. But there are cases that do take trees, you're correct, now that I think of it. There's a lot of them actually for all the build nodes, or all the build functions. That's true. Wonder, for that one, you take a tree base, a pointer to, you take a tree base because it can cast upward. And slicing for the proxy objects is okay because none of them have data members except for a tree-based proxy. So that would work. It would implicitly cast. Everything's good.
If I may, so this may be one of these areas where, as I was saying, different people have different comfort levels with C++, and this is where maybe I shouldn't admit this with my manager a few rows behind, but I don't really know much about std initializer list, and so I'm kind of going to nod and smile as the two of you do it. But this, this is, I guess, an example of.
I actually don't much either because I.
Yeah. Okay. And I was kind of hoping there's a slide where you show an example of how this might work, but yeah.
Yeah, I can probably easily mock one together very quickly, but you just do curly brackets.
In an initializer list, just you have a brace enclosed list of things with the same type or convertible to the same type, and the compiler builds up a backing array and passes a struct, which is just the pointer to the array and the length, and
you got to begin and end,
and you can do a straightforward iteration over it. The range-based for loop. It's
Packing up a variadic call.
yes.
And then consuming that variadic.
Yes.
Variadic arguments. Yeah.
The only difference in usage is that you need the curly braces around it. The original case for it, I think, is mostly for classes, not usually used as parameters, but I look at it and I go, even if it's not the intended use case, it kind of works here. The reason I don't like it, just really quick, is that until what was it, C++ 23 or was it 20? You might know, but they fixed a problem with it where it was not permitted to store what you pass to it in static memory. So it would really impact performance in a lot of cases. But that's been fixed. It was a defect report against C++ 11, so we do get those benefits.
And this is where I guess the question is, for any particular feature in C++, like std initializer list, I think I want to ask Jason, like, so in the GCC 4. Well, actually, what is our minimum baseline build requirement?
I'm trying to remember if it's 5.4 or
5.4, apparently. Yeah. Like, how solid is the code to do this? And are we likely to run into compiler bugs? Are we likely to be run into areas of where the spec was back then was less tied down, or that sort of thing?
I wouldn't expect trouble.
Mm-hmm. Yeah.
This one's very simple.
Yeah, I know, but I think for every aspect of C++, that's the thing we're gonna. Well, I'm gonna. Jason, does this feel safe to use? And it sounds like for that one it is. Yeah. Thanks.
So for sure, I agree. That is something, for every new thing that we use, we're going to have to ask ourselves, is this safe for bootstrapping purposes? And it does get a little hairy.
There's a nasty thing here, which is that how easy is it to accidentally depend on something that's beyond C++ 14 as you're writing it, where here I am on my laptop or whatever, using my nice modern GCC to work on the next version of GCC. Am I going to accidentally use something that's like C++ 17 or blah, blah, blah? Like, yeah.
I don't think so, personally. I do have one case where
I believe that stage 1 is built with -std equals C++ 14 to avoid this very problem.
I guess you were also asking if you aren't compiling at the time as well. So you're like on a plane and you do a whole patch, you don't want to compile to save battery. And you realize when you get off and you go to compile it, oops, that feature C++ 17. It's just a matter of knowing the features, which not everyone is going to, but I have a feeling that the people who know what's in the modern stuff are going to be more familiar. The people who are eager to use that stuff are going to have a better idea of what's new. Like fold expressions, I love them. They're in C++ 17.
Yeah, for myself, it's like while I'm developing a patch, I'm just doing it with bootstrapping disabled, and it's like it's only and then when it comes to sort of tidy it all up and make it presentable to the world, I then do a bootstrap kind of thing, and there's this whole workflow. At which point it's like at that point I find, oh crap, I've used something from the more recent C++, but at least it breaks before I send it to the mailing list, kind of thing.
You're reminding me of something I was considering for a while. I was thinking, wait, what if there were subsystems that we didn't need for compiling, like the diagnostic subsystem? Maybe we could actually use more modern versions of C++ in there and just be like, well, they don't have to work for that. But then I thought about it, and it's so limited. Those cases are limited, and it just sounds like a nightmare. It sounds like a headache waiting to happen, so maybe we shouldn't do that.
There's a whole bunch of interesting refactorings of the diagnostic subsystem that I want to get around to at some point, and more modern C++ versions ain't going to help, kind of thing. There are interesting tangled problems to deal with, and I'm happy dealing with them in C++ 14. Or at least I'm accepting that dealing with them. Yeah.
I certainly feel the same way. The only thing in C++ 17 that is helpful is full expressions. And unfortunately, there are a lot of things with variadic templates that are very hard without them. You can hack them in, but they are really hard to read.
By the way, is this a 1-hour session?
Yes.
In which case we're 3/4 of the way through.
Excellent, because I'm kind of pulling for time.
Oh, okay.
Yeah.
So whether you have more slides or to talk.
No, I have these ideas. This is actually really, we can, if anyone wants to chime in, absolutely. This is what I came up with. This was the missed topics that I came up with, and we were moving through them a little more quickly than I expected. I expected like at least one of them there would be controversial opinions on, but or rather it would be controversial for people. Yeah. But I suppose not.
Yeah, Alex, as you were enumerating your bullet points, I think you kind of didn't do the final two.
Yes.
So what are the ancient utilities? And also the low-hanging fruit, what you listed sounds great, and I heartily agree. One I would add there is using null pointer rather than uppercase null.
Well, null tree is kind of more idiomatic.
Null tree is useful, yeah, but I've been basically,
I agree.
Lately, every time I see a use of null as I'm editing, uppercase block caps null,
as
I'm editing a line of code, I will just do a drive-by, change it to null pointer as I go. And what's the other one I've been doing?
One of the ones that get to me are a lock A, because that one, I've come to the conclusion that it's never correct to use it. I know it's.
So what was that last thing?
Alloc A. So the stack allocator.
Yeah.
I know for embedded that has its use cases, like very many use cases in embedded, but I've come to the conclusion long ago that you either know what your maximum is and you use the maximum, or you don't and it's a crash waiting to happen, or an overflow waiting to happen, a stack overflow.
Yeah.
Yes, exactly. So that would mean alloc A is not a good idea though.
Do we use that?
Yes, in a tree check failed.
But that's crash handling. I
Yes.
mean, you're about to crash the compiler and bail out.
Well, you don't
anyway.
want to crash when you're trying to crash the compiler, right?
You what?
You don't want to crash when you're trying to crash the compiler.
Yeah.
Is it like a variable size? Or?
Yes. The question was, is it a variable size?
And is it unbounded?
Yes, it is unbounded. Yep.
In that case, it's a bug. It should be.
Yes, I agree.
It should be fixed.
Thankfully, I am refactoring that one. That's one of the ones where I considered using std initializer list. So yeah, that's one of the ones that I thought. Well, not quite std initializer list because I would make an array and then pass as an initializer list for the case that uses it. And it's very easy to bound, especially in tree check failed. Okay, now I have to think about this again because some of the things that I want to do change those assumptions. Okay, what I'll say is that I do think there's a solution to fix that one. But that's why I brought it up, is that do people think it's important to get rid of that? I think it is, and it seems that we agree.
Sorry, what was it you want?
Allocate.
Allocate.
Yes.
So one of the things that we did long back in glibc was for every allocate call that does not have, that has variable arguments, variable input, which doesn't have a bound, which means it could be an arbitrary number. It is essentially a Stack Overflow waiting to happen, right? So what we do there is we either convert that to a malloc, or we convert it into an mmap.
Mm-hmm.
So in this case, it looks like an error handler, which means you're on your way to a crash, and you want to, I'm assuming, print something and then exit, and you're allocating a buffer to print,
Yes.
right?
The case in particular for this one of them is to build the string that we're
Right.
printing.
Yes.
And there's a variable amount of tree codes that you could pass in, so the string could get quite long. And
So I
quite
would
frankly,
say,
sorry, yes?
so I would say in glibc, there's assert fail.c, assert/assert fail.c, where we do something very specific for this kind of use case, which is we allocate a buffer, write the string into it, and then exit. If that allocation fails, then you fail silently. That's basically how, and I think that should probably be standard
Something like
operating
that, for sure.
procedure for every C program.
I do
pretty
have my
much.
ideas on how to fix it. It's not like actually fixing it doesn't feel too complicated to me. And I will admit, there's not a lot of cases where it will actually do that, where it will actually overflow, because it's not dynamic by runtime, it's dynamic by how the utility is used. Yeah.
It's bounded by the calls.
Well, no, not runtime. Yes, exactly. It's bounded by, it's a static call to it in all cases. So it's for tree check, you go, is it this, 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 or this? So there is always a theoretical maximum that you're going to be passed to it, but
So is the theoretical maximum safe?
that's the question.
Safe, then it's okay.
I personally think that, well, that's the thing, is then you should use a fixed array, right?
You either use a fixed array or add a comment over there saying that this is the maximum that this buffer is going to be.
Using a fixed array means you have to keep it in. Using a fixed array means you need to keep the number in sync. Like when
Yes.
if you add a new tree check 7 or whatever, would be the next one.
We can trivially detect that even at compile time. That's a little expensive, but we can definitely assert for that very easily as well. Well, assert's probably the wrong choice there, but you just max out and just silently drop the last ones maybe.
Okay. And this isn't, I suppose, how do people feel about stood string rather than doing all this manual buffer management for building up strings?
I'm of the opinion that it's not a good idea there, because
not.
while they use the dynamic allocation in their case, I do think putting it on the stack is correct. It should just be explicit in what the maximum is, because you're at a point where you're failing already. I don't want to make allocations in error handling, or not in error handling, but in like icing or something, which is effectively an internal compile error.
Yeah, but when an ICE happens, for example, the Serif backend attempts to write out a full valid Serif file
Okay.
with a backtrace, and all kinds of things like that.
Okay,
and it
maybe
might
I'm wrong,
and it
that's
might
true.
crash doing it on the way out, but what? Yeah.
Although I would argue, I have some apprehensions about using stood string or the standard library in general, but that was kind of inflicted on me.
Yeah. I was going to say, just on a sort of going up a level, in terms of modernizations, we have a lot of old code in GCC that is doing C-style string manipulation.
Yes.
And it's
That could have been on here. I think.
so basically I've been increasingly over the last few years just it's like, oh sod it, I'll use stood string, and then realizing it's so much easier.
It is.
And it's not going to interact well with the garbage collector, and that's something but it's just wonderful to be able to use it. And I guess I have the advantage that my code isn't particularly performance critical in that.
Neither is this, though, to be fair, in this case.
In tree check failed, just switching
Yeah.
to. In tree check failed, I think just switching to stood string makes a lot of sense.
Okay, awesome.
That's.
Also, just a drive-by comment, has not Jonathan Wakely rewritten the driver to use standard string instead of all the, so the GCC.c
Okay.
driver? I think, yeah, because we discussed that before, I think, but that never got upstream for, should chase that down.
So on the subject of C to C++ cleanups, do you also want to switch the dump handling over to C++? Right now it's using the IOStream fprintf stuff.
No, I don't think so. We justify
Why
it
not?
very, because his diagnostic checks are very good. And so I think that the C-style printf and whatnot is actually very safe, thanks to David Malcolm.
Well, no, that's W format, I think, but yeah, it wasn't me.
Oh, okay. There we go.
Are you thinking of like, I have a pet peeve with
Oh, can we, Mike?
No, I don't have a pet peeve. It's just a suggestion.
operator less than for like in C. So I do have a pet peeve, which is the operator less than for streaming things in C++ and all of that. Whereas, can we just use format strings instead? It's translatable. It's blah 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 blah.
Do you mean printf format strings?
Well, some of the sort of format string style API rather than the
So
operator less than, where you pretend it's make it look like a.
Oh, are you talking about for a string comparer?
No, for string, for piping things into an IO stream, the sort of C++ idiom that Bjarne
okay, I see what you're
invented.
I don't like that either.
And I hate.
It's actually bit shift, is what you're thinking of.
No. So
Oh, is it?
Oh, less than. Yeah, you're right. You're absolutely right. You're absolutely right.
Well,
Sorry.
it's an insertion operator,
Yeah.
is what they call it.
We have not had much time. There was one of the
There's no talk after this, so if no one
okay.
wants to go anywhere, I'm happy to continue.
There is
Not in this room, sorry.
Yes, yeah.
There is?
Yeah. Okay. We have 6 minutes.
Okay.
One modernization I wanted to mention that another drive-by modernization I've been doing to my code is enum class rather than with then lowercase names rather than
I have my
uppercase stuff, which
yes.
which is I think a nice simplification. I don't know if it affects the ABI, but as I say, the stuff I'm working on isn't particularly performance critical, and
It's
the memory
like
doesn't
Jason
matter,
said.
but whatever.
There's holes everywhere.
And
so
the other
don't
thing
worry.
is I'm intrigued about removing ancient utilities.
That would be
I don't think you've
alloc
spoken.
A.
What?
That would be a lock A.
Alloc is a.
Yes.
Okay.
I've considered. Well, I guess it would have been more accurate to say obsolete or just. I wrote it in a hurry. I couldn't think of a better way to phrase it. But alloc A, the C-style string processing instead of std string, stuff like that. That's in the spirit of ancient utilities. Things that are considered harmful, per se.
I mean, if you're not using std string and if you're sticking to alloc with fx size, you could instead transform it to a VLA. So that would be more idiomatic, I think, compared to
That's not C++. Nope.
a VLA.
Yeah, VLAs are not C++. Do we support it as an extension? Okay. Are we worried about any compilers that don't support it in C++ mode?
I don't think we should allow it because
Okay, I agree.
14.
Yep, there we go. So not C++.
Because I think there's nothing in this room. There's something in B3 because it's a bit arms related.
I did check the schedule. There's nothing here unless something's changed. Okay. Okay, cool. All right, well,
Because MTE is still listed in the website in B3, which makes sense because it's related to ARM, and ARM BOF was in B3.
okay. Well, I can absolutely get out of the way, and then if anyone wants to talk about more stuff, I'd love to.
Yeah, I see things in B32 and B3, but not here.
Yeah. I mean, I'm happy to keep. I'd like to keep talking.
I'd like to keep talking. But if anyone needs me to get out of the way, absolutely.
We have 4 minutes.
Pardon?
We have 4 minutes.
Yes.
So, types of predicates on the wiki. Obviously, it says
Yes.
that we cannot trust that it will be a bool. We have to trust that eventually it may be converted to some kind of int. Does anyone know of any case where this has actually been enforced, where the type of the bool has, or rather the type of the check has diverged from 0 or 1 to a
I think I
more
can think
generic
of one.
integer? Does anyone know of a case where that's even happened? Because it's one of the things the wiki says, but I've never run into it.
I think I've seen one. But in terms of that, I think we want to replace that with enums.
I mean, there are various places where they use a return value, which could have multiple values as a Boolean.
Yes.
And there are some cases where we have like tri-state returns or enumerated returns.
They
And
certainly exist. I think they shouldn't be int though. But the cases that are explicitly 0 or 1 should be bool, and there's plenty of them. And that's what I consider low-hanging fruit, because we should be able to change it, and it should work without any breakage.
Yeah. So there's like something I did in diagnostics is we used to be passing int around everywhere as the option controlling command line options. There's an enum value that's separate, and I created an option ID class that wraps the int, so at least it is what's the word? It's describing what it does. It's expressive. And there's one Jason. There's one I was playing around with my experiments with some of the C++ stuff. I do need to send you these patches, but I need to finish them first. That there's like an idiom in front ends, or at least the C family. I think there's an argno, because sometimes we're referring to arguments as a zero-based arguments at a call site with a special, and -1 means this, I think, and there's some extra, I can't remember the details. And but there's the other standard, which is this is the how we present this to the user, where we want it one-based, argument 1, argument 2, and I was thinking, can we have, rather than having ints for all of these different things, well, these feel like two different concepts that could be classes that are wrappers around int, but describe exactly in the type system, this is a human-facing argument index versus this is a argno or whatever that we want to call it. And I think there's some nice cleanups we could do there.
I'd like to interject really quick as well that I fully agree. I just wouldn't put it under low-hanging fruit. It's a little more difficult.
that's an ancient pattern that I have no attachment to.
Excellent. I guess we can officially wrap it up here because a lot of people have cleared out anyway, and I'm realizing that I'm quite thirsty. Yeah. So thank you everyone for coming. I had a great time, and this gives me a lot of ideas of what we should be doing. Although I'm sure I will have some people contacting me after they watch the recording with opinions. And to anyone who did watch, please do so. I don't want to turn this project into something that you hate. I want to turn it into something that everyone loves more. Thank you.